Welcome to myprojectBazaar.com.
Now we can going to discuss about the product, a resynchronization of distribution generation based on the universal droop controller for seamless transfer between operation modes. Next we can going to discuss about the abstract of our product. The proposed system is an implementation for the distribution generation. We are using the different types of distribution generation, and we can using the different types of operating modes, like for the island mode and grid connector mode. These two modes are very intention of the microgrids, and these are very, we can analysis for the magnitude and phase angles. We can find out the voltage derivation for that microgrid, and these microgrids are connected from the main grid using such more different conditions like overcurrent and harmful to the system. This paper presents the new architectures for the simple and economic process, and this is a synchronization mechanism for the droop control. These droop control is verified our process for the island mode and grid connected mode. The simulation results are very effectiveness we can provided, and this awareness of seamless will be connected to the main grid, so we can lot of distortions will be reduced to this process. Next we can discuss about the flow diagram of your product. These are using types of DC source. The DC source are input for the 400 voltage input for the DC source. The DC are connected from the common DC to AC converter. These converters different types of switching pulses are given, and these converters using the 6 switches using the IGBT switches. The IGBT switches are connected to the common change the convention the common AC bus. The AC bus only 3 we can segregate this to the AC grid, and this local load nothing but we can use some substations and different types of load, and we can using this local load for resistive load will be important, and these control pulses will be given to for synchronization method for the droop characteristics method, and integrated with the PWM method. There is a self-synchronized universal droop controller, and they are using the different types of transfer function to control PWM pulses. The reference PWM pulses will control for the DC to AC rectifier. The entire blocks will be corresponding to the our AC circuits, and of our DC generation, and totally we can through for the our AC power. Next we can going to discuss about the running procedure of your product. The proposed system implementation done in MATLAB version 2013A. The corresponding scopes are connected from the circuit diagram of your product, and the scope blocks are connected from the from two functions of the product. Next we can see about the block diagram of your product. This is our circuit diagram of the product. This is our DC source. This and this pink color marks and DC source. This is our bridge rectifiers, and this is our line control parameters, like we can RLC something, and this is a common AC bus, and this is a load, and this is a grid. Everything are connected in the corresponding scopes are connected to the from two functions. These are scope blocks, and this is our control circuits for the our block diagrams. This is our synchronization block, and everything will be connected to the subsystem of the blocks, and these are control pulses, and these is on corresponding scopes are connected to the from two functions. This is on two functions, and first we can see for the grid voltage and grid current. These are grid voltage and grid current. First this 0.3 transient mode will be operated at the grid connected mode, and this is moved on to the island mode. For this current will be fully zero, and it will be automatically on, and this is a reconnected grid connected mode, and this is load voltage and load current. This one load voltage, and this one load current, and this one nearly amplitude of 0.3 something will be breaker will be off, and it will be on, so we'll be getting the sinusoidal pulses, and this is an DC voltage, the DC input voltage for the 400 amplitude range for DC common DC voltage. This is an inverter own current inverter. We are using three inverters. This is an inverter own current, this is an grid current, and this is an load current. So this is a different categories for the load and the inverter and the grid. This is a inverter 1, 2 and 3 current. We are using the ampere ranges for the 10 maximum ampere range will be getting that inverter current. This is our control pulses to control our switches like inverters. We have 6 switches we can using that. These are S1, S3 and S5 and S2, S4 and S6. These switches are randomly on and off. We can using switching frequency of 2000 kilohertz will be given to applied. This is an inverter on voltage and current. This is for real and reactive power for the inverter 1. This is an real power and this is an reactive power. This reactive power will be injected on real power, so it will get in the maximum level amplitude. This is an inverter 2 voltage and current. This is an inverter 3 voltage and current. And these categories will be generated on real and reactive power for the 3 different inverters. Will be find out to getting that results. This is an entire architecture and a simulate model of the MATLAB simulating modeling. This is our load. We can using the resistive load of this circuit. We can using that. So thanks for watching.